Once we have these agents, they're going to be at scale. We cannot no longer have the humans in the loop to govern or guardrail them. Then the logical thinking would be, right, oh, can I create another agent?
Welcome to the Talking AI podcast, where we talk AI with both experts in the field and early adopters. I'm your host, Matt Paige, and we're here to demystify AI for you so you can get some value from it. Let's talk some AI. You hear a lot about AI agents nowadays, but how you orchestrate and architect these agentic systems, along with considerations of human in the loop, real-time requirements, and a ton of other factors become really critical. But lucky for you, I'm joined today by Praveen Gunasekaran, Senior Director and Chief Architect at Visa, alongside HatchWorks AI's own CTO, Omar Shanti. And Praveen brings a ton of experience from roles at Visa, Wayfair, and Microsoft, where he specialized in building reliable, high-speed machine learning and AI systems for enterprise environments. But you guys ready to talk some AI?
Yeah.
Awesome. Praveen, let's get it kicked off here. Just to start with like basics for our audience, how do you define agentic systems from your perspective?
Agents are anything which can, automatically make a state change to your system in your business process, right? It's not just, we are not just talking about the chat-based information where you can retrieve information or you can understand some information, or even sometimes help you to automate or autocomplete some of your tasks, right? But here we are looking at if that agent can make an actual state change or a business process change within your system, right? That has its own challenges because so far the couple of use cases which I talked about, the chat based or even like able to complete something which you're doing, there is a human in the loop, right? But when you're looking at the system at an automation level or business problems, there's generally not a human in a loop, right? Because you're looking at scale. So how can you build a system to be reliable, secure, and also available all the times is the bigger challenge here.
Yeah, and when you mention like right when you said state change to your system, like I think the hairs raised up on my back, the back of my neck a little bit, because with it like AI and agentic systems, like they are probabilistic in nature, right? So that you don't always know the outcome. I think that's like the interesting thing. And when we were chatting earlier, Praveen, you mentioned this idea of like agentic thinking, like traditional software development, it's deterministic. I know or I should know, what scenarios are going to happen. You're developing the software for those. But when you're building an agentic system, it's different in that sense, correct?
Absolutely right. I mean, that's actually what's exciting, right? And why I'm really excited about the agentic system is before software engineering, it has to be very deterministic. I would even say that you have to stupid proof the system, right? When I mean, you have to code everything, like about everything and everywhere about what that software has to do, right? At times of limits what the software can do, right? And that's why coding or programming is hard because you have to look at all the use cases and you constrain them. Like lucky that the systems are constrained within your operations or whatever you're doing. So there's only finite set of states available, right? And you code to it. But that means like the number of people who are involved in it is it's not many, right? It's really hard. There is um, the correct word would be like to get started with the systems, right? It's limited. But now, if you have a human-based conversations, like the thinking is, okay, here is my problem statement. These are the bunch of tools or functions you are available for you. Now go figure out what's the best way to solve this problem, right? That's powerful, right? That means anybody who can understand this nuance, which most of us can I get access to the use of computers, which is profound for me, right? Which is kind of democratizing your technology. That's why I'm very excited about these agents because it's the actual word I was trying to look for is like the entry to barrier to use compute, which is a powerful resource, is going to be really democratized and available for everybody. That's what these agentic systems and LLMs is. I think that's where the biggest revolution that's coming up, right? And that's going to give us a lot more productivity gains, a lot more people who can express, use the power of compute to do what they want to do. And we don't know what they will all do, but pretty sure they're going to do something good with it. Yeah, that's why I'm excited.
I think the excitement level is huge. I'm curious, like Omar, from your perspective, like there's the one element that's like oh my gosh, I can do anything with these systems and I can kind of just direct them, point them in the right direction, and they have the potential to execute on those tasks. But Omar, I guess the flip side of that is they could also do things that you don't expect anti-patterns, like bad things as well. And the immediate thing is like, oh, I have to control this. I have to put in guardrails, which may not also be the best approach either. Omar, how do you think about that in a sense when enterprises are starting to like dip their toes into this agentic approach, agentic way of thinking?
Yeah, well, the key word there is governance, Matt. And governance is a set of muscles that enterprises have gradually become more and more likely to flex in the realm of data and AI, even in software development. Governance sort of couples the technology with the people and the processes, in the triad that we're all familiar with. And some of the considerations of governance are around ownership, accountability, accuracy, and even as you're mentioning, Matt, sort of like putting some bounds and some guardrails in place to prevent worst case scenarios from occurring. I like to give the example of a call center transformation. I think the statistic is something like a call center achieves roughly 85 to 88% accuracy. You could put a chatbot that might be able to hit those numbers. But the question is, what happens in the 12% of the time when it's inaccurate? What guardrails are there? In the case of a call center agent, they're not going to agree to sell you a Tesla. They're not going to agree to give you a free car. Whereas, as we've seen publicly with some call center or some chatbots on the websites, when an error happens, it can be very costly and have major ramifications. So it's really important to think both in terms of the quality and the quantity of the errors that might occur and the negative sort of consequences, and to put guardrails in place. And you can sort of adopt the same kind of prioritization matrix that you already use. So if you prioritize things based on customer satisfaction ratings, then certain things might be worthwhile to patch. Certain attack vectors might be more worthwhile to patch than others. We see something similar with data quality. An organization's got bad data quality. Where to begin? Well, with the most valuable data. And so over here, when it comes to governing your models, where should you begin? Where the value lies.
I think the other interesting thing too, I'm curious, both of y'all here, you use almost an element of like fighting fire with fire, right? So if we unleash these new agents into the world that have this, probabilistic approach to things, well, you could have agents that are tasked with making sure those things don't go off the rails. So that becomes its objective in a sense. So you may not explicitly know what negative things are going to happen, but you can have an agent that's watching out for those. Is that a logical approach? I'm curious if either of you have seen that in action. Is that a different way, I guess, of thinking, enterprises thinking about this?
No, definitely, that's an interesting idea, right? Because now once we have these agents, they're going to be at scale, right? As I mentioned, we cannot no longer have the humans in the loop to govern or guardrail them, as you mentioned. Then the logical thinking would be, right, oh, can I create another agent, right? We are already seeing the early versions of this. You would have heard about this concept called LLM as a judge, right? Where you're using another smaller LLM, like not that as powerful as the initial reasoning or the thought LLM has to, but the thinking comes from it's easy to verify a problem than to solve a problem, right? We can all understand and experience music, but we cannot all make music, right? Maybe now we can, but that's the thinking.
Right. Yeah. That analogy doesn't hold up as good nowadays with generative AI, right?
Yeah, now you can have Suno.ai, which can make music for you, but still the creative process involves. So similarly, there are concepts like there are some recent research I've seen where we create other agents, right? A quality testing agent or a reliability agent, right? Which checks how good the system is doing, right? How the specific unit of agents is saying. Another important concept, like as you're alluding to, more of orchestration, right? Because with agents, what you need to do is, I feel you should not give them a really big problem because we are very early in the space, right? Define them into really small unit task where the complexity of the task is small enough so that you have a better ability. The agents can like able to solve that in a better way, and you can have other agent testing to start with, because we are very, very early on this journey, right? You don't want to like jump deep into the ocean. Let's put your feet into the water and wade it slowly and learn as we go. So thus you have to put caution with how we are doing, because these are powerful systems, right? You don't want to take this really powerful thing and start on the wild, right? You want to slowly wade into it. Yeah.
Yeah. So that's all right. So that's such a good thought process there, a principle. So listeners that maybe aren't paying attention or kind of zoning out, like come back to us real quick, because what Praveen said there, I think, is critical. Breaking it down into smaller elements that the agent is tasked with, right? Versus giving it this like autonomy to do anything and everything. If it's honed in on something very specific, it's almost like you're building a house out of strong composable bricks versus a house of cards that, may get knocked over very easily. That's a really smart approach and way of thinking about it there.
So just to piggyback off of that, there's so many directions to take that, but we've been long advocating on this podcast that the future that we're driving towards is a multimodal, multi-model, multi-agent ecosystem. But let's build up to that a little bit. First, let's go back to what Praveen mentioned around LLM as a judge. So when this sort of advent occurred with generative adversarial networks, GANs, I think that's the right sort of elaboration of the acronym, you had a network training and testing another network, right? So from the very core of the architecture that brought us LLMs and these sort of generative technologies is the same pattern that we can reintroduce to test. So LLM as a judge is swapping network test network for agent test agent. And we've spoken about this on previous projects as well. But if you want to think about the failures of traditional unit tests when it comes to a probabilistic system, you'll sort of realize that something probabilistic is best suited to test another thing that's probabilistic. You can contrast the syntax from the semantics, and by that I mean the individual letter to the meaning conveyed. Typically, when we test software, we have to test the individual letter, the value of the byte. But right now, when we're working with agents, a lot of the times we want the byte to be flexible. That's why, we don't all have our temperature set to the setting that minimizes variability. We want that variability because that's sort of the root of personalization. But if you want that variability, you also need variability in your testing. And that's why agent test agent is a great pattern. But so to go back to sort of the broader question around how to test agents at scale and, what this could sort of evolve into, one thing that we've been seeing on the market, Matt, is sort of a step to centralize in order to decentralize. So a lot of our interlocutors are building up single AI gateways that sort of connect the user to this graph of single purpose agents, which are each finely tuned to perform one task. It's sort of like this Unix moment, right? Where you've got all of these functions that you can reach out to. And there's some form of communication so that these agents can invoke each other as well. So it starts to resemble almost like a service mesh turned into an agent mesh, if you will. So it's really fascinating the way that this field is heading.
Yeah, just to add to it, where Omar was going is like we're going into a world where we're gonna have, since you mentioned Unix, we're gonna have a newer way of operating system, right? An agentic operating system, what that world looks like. Because once you enter into this huge AI, which is gonna orchestrate smaller pieces on it, like all of these functionalities which you're gonna require the smaller agents. You could have millions of them, right? And even in the world, the more writing code become very simple, easy, right? You don't have to build a software and keep holding and managing it. You can create things as you need on the fly and destroy it and use it, right? So that's an interesting concept that can happen too. So yeah, we are going to where there will be a OS operating system you might see. Yeah.
Yeah, it's a totally different paradigm and way of thinking of things. And I just keep trying to remind myself how early we are in this evolution we're experiencing right now. Like we're very early days. It's like back in the days of, the internet, we're in the dial-up or maybe even earlier of that in a sense. But one thing that's interesting when we talked last, you talk about these agents having different tools. It could be an API, which is how in a lot of ways computers and whatnot, they talk to each other through APIs or solutions and services and whatnot. CPU to run math or do something like that, a database, or even working with other agents. But, and you may have been hitting on this a bit just now, Praveen, but are APIs going to be that standard that persists? Do you see a new protocol potentially evolving outside of that, or does it continue to work in the same paradigm that we've been seeing?
So I've been thinking about it, right? So, and initially, because APIs, all of these are defined by humans, right? The APIs and the message protocols and stuff. And I see earlier enough what I'm seeing that currently also, we're just going to use the existing interfaces, right? You call the APIs and just you're going to call them as an agent, but the agent is internally calling an API, or it could be even calling a function. But what I see as things, the more and more, we're not going to be building APIs long as more as we are building now. That's not going to be a de facto way of building applications, right? Going forward. Now, you want to build in an AI native and an agentic native way of doing things. What would it look like, right? How would the interface be like? I mean, it's not completely clear. The verdict is not out yet. Is it like a chat-based interface, or how do even agents talk to each other? Maybe the agents can come up with their own protocol, right? Because APIs are written for our understanding. The docs and things go out of the box, right? But if the agents, it depends on what optimization function you want to give this to the agents, right? For the problem to solve, maybe I directly converse in bytes, or even like an other form of information, which it's more accurately it can measure or reliably other agents can understand. So it's kind of fascinating that point where how this messaging protocol between agents going to evolve. But for now, it's going to be, we're just going to put APIs and use them because most of the existing interfaces available like that. Yeah, that's what I see, but it's very fascinating.
Consider that REST APIs are simply abstractions over HTTP packets sent over a network. It's an abstraction that worked for a lot of the sort of single page applications and the recent turn to like web and mobile technology over the past 20, 30 years or so. But ultimately, there were predecessors and there's competitors even now, gRPC, SOAP, WebSockets. And within your operating system, there's all of these channels for inter-process communication so that you can trigger others and so on. So all of that's to say that at any point in time, there are dozens of these sort of protocols, communication patterns that coexist and that are in a niche. And I think I share with Praveen that the niche has yet to be discovered, and there's no reason that it needs to be a REST API whatsoever when it comes to agents.
Yeah, it reminds me almost of like how self-driving cars have emerged in a sense. They're kind of working within the paradigm and the way we drive cars today, but that may not be the end state if those actually start to proliferate and everybody is using self-driving cars. Similar here, it's working within the current ways of working that's been tailored to us as humans, but that potentially completely evolves in the future. But Praveen, when we were talking, you mentioned back at Wayfair, you were working in some solutions where you needed like 10 millisecond inference speed. And then you get into this concept of like real time. Do you need real time? And when you do need this like hyper real time, sub millisecond type of scenarios, how does that impact your decision making from an architecture standpoint, from leveraging cloud or not? Like what are the impacts there when you start to get to these like crazy real-time type of solutions?
So, it depends on the business problem, what you need to solve, right? Because when you go real time as near real time as they was talking about milliseconds, right? Not all, first of all, you need to see, is there an AI solution as a right solution for it, right? Machine learning, inferences takes time and they are expensive enough. Okay. So first you need to understand that question. If it is, for instance, the way in Wayfair, the problem I was working on is predicting the delivery time. So it's a prediction. By definition, yes, you have to use ML, but can you use any algorithms, right? Probably not deep learning algorithms. Like there is always constraints and computes on it, right? Once you have that understanding, then you need to look at cloud, because what people will people who work with cloud will get you started very quickly, right? But the stickiness of the cloud and the cost you will have to spend later, you might get some credits early enough. It makes a lot of sense, right? To quickly, but after 6 months or 1 year down the line, your cost may not amortize, right? It may actually keep increasing. So depending upon the scale of your organization, right? And the problem, is it your core problem that you're going to solve, right? Do you want to own the hardware by yourself or not, right? It's going to depend from business to business. For example, in my current organization, where we are big enough to own some of the hardwares we want, right? But in Wayfair, the use case was they wanted to be fully on cloud. So they were okay with that cost. So there's no one solution, but you have to be very careful about the problem which you're solving, right? What is the cost analysis of it, right? And is it something a core problem for it? Can you take this, the architecture or the solutions which you are doing to any cloud? So one of the ways I proponents in my current organization is because we run in multiple clouds. We have our own clouds. So I don't just build cloud native, I build it cloud agnostic, right? Cloud native, there was a concept like, let's build it cloud native. But what does it means, right? Using systems very specific to that cloud will keep you tied to that system. For instance, if you use AWS, if you use their PubSub, use their Aurora DB, you're just stuck into it, right? If you want this, they say, yeah, you can take it and move it into another system, another cloud, but it's not that obvious, right? Migration, we all seen migration. Migration is never easy. It's the most difficult thing we all do. So the answer is complicated. It is depends on the business, but few principles I say is keep it cloud agnostic, right? Wherever is required, understand your business problem. If it is a core problem, and if you can amortize your cost, the upfront RPC cost of the systems, go with it. And the third thing is build it in a modular and a composable architectural way, so that the underlying technology, if they increase and make it better, you can always lift and shift, move your parts, and be able to run on it.
Yeah, such a good perspective there. And to sum all that up, it depends, right? At the end of the day, it depends. But you got to take that business context in there as well. I'm curious. I want to get spoken like a true consultant, right?
So another thought here. That's why I'm not worried about my job. The AI is not going to solve this job pretty soon.
Yeah, I think we got a little bit of bandwidth before that happens for sure. So I want y'all to riff on this topic. We touched a little bit on this, but y'all brought up a really interesting idea around event-based streaming architectures, which that in and of itself isn't necessarily something new or novel, but then you bring agents into the mix where these requests may be streaming out there, and it could be an agent picking it up, it could be something else. But I'm curious, thoughts on that, and I'll let y'all just kind of riff back and forth here for a second on that as an architecture approach or pattern, what that can mean, where it can be best used, and whatnot.
So I'll offer some thoughts first. I'd say thinking about the protocol is crucial, because that's what sort of systems are built on. Systems are built on understanding what subcomponents within that system do, what they take in, and what they return. We've been seeing this trend within the field of LLMs in general, of supporting things called structured outputs, where you can sort of dictate what the format of the response looks like. That's brilliant because that starts to approximate the sort of protocol that Praveen and I were talking about earlier, of having, very clear contract, what you get in, what you get out. Add in things related to SLAs, service level agreements, which can be like availability, time to execute, or time to return a response, uptime, etc. And you start to more or less productionize a system around agents, so that you can chain together these modular functional pieces without losing confidence in the system as a whole, because everything is governed by contract. I'm really interested in bringing this level of mesh-like governance to something like a multi-agentic workflow, because while a lot of our conversation focuses on the technology, this helps us sort of shift left a bit to the people and the processes. One thing that we can sort of take one sort of new exciting trend that we can glean into is the development of data contracts. Data contracts sort of stipulate what a data store contains, as well as how change management will be conducted. We want to drive towards a system of multi-agentic workflows. We need to see what the data product and data contract teams have been doing so far, pair that with what the service contract teams have been doing, and then find a nice synthesis unique to what you can achieve with agents in a multi-agent ecosystem.
Sure. Absolutely. So if I had to add to what Umar was saying, right? Because I feel for agents, an event-based system actually fits very well. The reason being is most the agents are today is not going to be quick enough, right? They're fast enough. They have to do the reasoning. They have to do the planning. They need to try multiple times. Like a system has to work, or they may have to do multi-turn or even multi-agent or process to come to a problem, which means that you gotta give it a request and wait for it to come back. Okay, which is kind of an asynchronous way, and events is by definition you don't expect a response out of the box right there, right? So the early adoptions of agents is not going to be on the real-time systems, right? Where there is you don't want to be using them for financial services where I swipe a card and there is an agent which is okay. I'm going to think about it. I'll tell you when it is fraud. You don't have that time, right? People have less than half a second, maybe less than that. So when they swipe a card, a process happens. But you can take all these transactions and you can put an agent on the back end. At the end of the day, where settlement happens, right? At the end of the day, the process that an agent can take. So which means an event-driven system, a batch systems, and which is nothing but a special case of your real-time systems, right? So which fits in very well to that architecture. So I see agents being good based on the event-driven architecture systems. That's where I see a lot of those developments are happening because you want your agents to actually think now. You wanted to give it a request and maybe depending upon the complexity of the task, it's okay. I'm asking you to write a new movie and my characters are defined. I can sleep on it and come back in the morning and it is ready with it. That's great, right?
Nice. Yeah, I think that's a great stopping point right there, to be honest, because at the end of the day, it's about using the right tool for the right job. And that's all this new technology is right now, is it's a tool to be used and you got to use it in the right way. But Praveen and Omar, thanks for jumping on, talking some AI with us today. Praveen, where can folks find you if they want to reach out or learn more about some of the stuff that Visa and is doing on the AI front?
Absolutely. I mean, you can always connect me on LinkedIn. LinkedIn is the place I'm being more active on. Yes.
Nice. Great. Awesome, guys. Well, thank you for joining today.
Thank you so much.
Thanks for listening to the Talking AI podcast. If you enjoyed the show, give us a follow or subscribe on your favorite podcast platform. And don't forget to leave us a review. We love those. For more info on Talking AI, visit talkingaipodcast.com. Do you already have a Gen AI use case in mind for your business, but don't know where to get started? HatchWorks Gen AI Accelerator is exactly what you need. We guide you from ideation to a tangible prototype. Our approach provides a low-risk, high-value pathway for you to validate and test Gen AI technology on a small scale before committing to full production. We take you through technology and LLM selection, perform data preparation, and then build the actual prototype. And then we do testing and model fine-tuning of your prototype. The best part is, we get you to this prototype in just 2 to 8 weeks based on the scope of your use case. Check out the link in the show notes or visit hatchworks.com to get started today.